Good morning students. Class 12th, chapter number 6 applications of derivative, lecture number 10 homework and lecture number 11. So in lecture 10 you were given exercise 6.5 question number 15 to 20. So out of those I am going to discuss two questions and then we are going to proceed with our classwork questions. So just to see here, question number 18 is there. It was your homework question. So it is said in the question that a rectangular sheet of tin 45 centimeter by 24 centimeters, we are being provided with the length and breadth of the rectangular sheet, is to be made into a box without top. We have to make a box out of it but without top. Now by cutting off squares from each corner, we have to cut out square from each corner of the rectangular sheet and then we have to fold up the flaps. What should be the side of square to be cut off so that the volume of the box is minimum? Now for getting the volume maximum, what we should have as the second order derivative of volume? Less than 0. And we have to find out the side of the square also that we are cutting from the corner of the sheet. Now just let us have a look on the diagram. Now as you can see, the length we are considering of the square as x. So from each corner of the sheet we have cut x centimeter length, right? So it is 45, the length is 45. So if you are cutting x centimeter from both the side, you will be left with 45 minus 2x. Similarly, with breadth, 24 is the breadth, we are cutting x centimeter from both the sides, so it will be 24 minus 2x. Now this is the length and this is the breadth. Now when you cut off the corners, you are going to fold up these 4 flaps that you get. So a box will be made like this and its height will be x. So what is the formula for volume? Length into breadth into height. So what is the length here? 45 minus 2x. The breadth is 24 minus 2x and the height is x. So we have to maximize this function first of all, right? Also at some value of x. That means our purpose is to calculate x and we should get the second order derivative as less than 0. Clear? So these are the two things to be done in the question. So first of all, as we see, v is itself a function of x only. So we will first solve it or simplify it. So we'll multiply first of all x with 24 minus 2x. So we will get 24x minus 2x square. Now multiplying these two brackets, we will get 1080x minus 138x square plus 4x cube. Taking 2 common, we will get volume V as equal to 2 into 540x minus 69x square plus 2x cube, or rearranging the terms we can write it as 2 multiplied with 2x cube minus 69x square plus 540x. Now we see this is a function of x, so we'll differentiate v with respect to x. So let us find the first order derivative of volume v with respect to x. So we will write d by dx of 2 being a constant remains out and we have 2x cube minus 69x square plus 540x. So just to see, we will get 2 multiplied with 3 2s, it will be 6x square minus 138x plus 540. So this is what we will be getting. Now we will equate it to 0. Now we can also take, before equating it to 0, 6 common. So if we take that, we will get 2 multiplied with 6 x square minus 23x plus 90. Now we will equate it to 0. Let us do it on a separate page. So we have the equation as 12 multiplied with x square minus 23x plus 90 equals 0. So we have x square minus 23x plus 90 as equal to 0. Splitting the middle term method, we will be solving the equation. So just to see here, 23 can be written as minus 18x minus 5x plus 90 equals 0. Taking x common, we get x minus 18, minus taking minus 5 common, we get x minus 18. So we are left with two factors, x minus 5 and x minus 18. So according to the zero product property, x value is either equal to 5 or x is equal to 18. Suppose we take x is equal to 18. So the length and breadth were 45 minus 2x and 24 minus 2x. So just to see carefully, if I put in the value of breadth, I'll get 24 minus 2 multiplied with x, that means 18 into 2, which is 36. So we get it as minus 12. So breadth can't be negative, hence x equal to 18 is not possible. The only answer left with us is x equals 5. So we will put x as equal to 5. Now at x equals 5, we have to find out the second order derivative of the volume, and we have to prove that as less than 0 for maximum volume. So what is the first order derivative dv by dx? It is 12 into x square minus 23x plus 90. So just differentiating it, see, we get 12 multiplied with 2x minus 23. Putting x is equal to 5, we get 2 multiplied with 5 minus 23. So we are left with 12 multiplied with 10 minus 23. 12 multiplied with minus of 13. You see, we are going to get a negative answer which is less than 0. Hence, we get the second order derivative of the volume V as less than 0. Hence, we have proved that the volume is maximum at x equals 5. So, from each corner, the side of 5 centimeter square should be cut off, and then we can form a box which has the maximum volume. Clear? So this was same kind of question as we discussed in the previous lecture. So in that it was a square sheet, in this it is a rectangular sheet. Let us discuss one more question from your homework part. So let us discuss the next question, question number 21. In this question it is given, of all the closed cylindrical cans which are in the shape of a right circular cylinder, of a given volume is given, whatever is given that we have to use. So what is the volume given to us? 100 cubic centimeters, right? Now we have to find the dimensions of the can. So what are the dimensions in the cylinder? The radius and the height h. So these two are the things that we have to calculate. Of the dimensions, which has the minimum surface area? So what we have to minimize? The surface area. What is the formula for surface area? 2 pi RH plus 2 pi r square. Of top and bottom 2 pi r square, and the curved one is 2 pi RH. Now using this volume, because it is given, using this we have to minimize the surface area and find out the values of r and h. So just see carefully, what is the volume? Pi r square h equals 100. Now we can find out the value of r or h from it, and can convert the surface area in just one variable, either r or h. So just to see, if I calculate the value of h from here, I'll get it as 100 upon pi r square. We will put from the equation 1 the value of h in s. We will get 2 pi r multiplied with h value is 100 upon pi r square plus 2 pi r square. So just to see, pi will get cancelled, r will get cancelled. We are left with 200 upon r, that can be written as r to the power minus 1 plus 2 pi r square. So this is what we have to. Now we see that our surface area just have one variable, which is the radius, right? Let us now differentiate it with respect to r. So differentiating it, ds by dr, we will get 200 as it is. Differentiation of r to the power minus 1 will be minus of r to the power minus 2 plus 2 pi as it is, and differentiation of r square is 2r. Clear? So we have minus of 200 r to the power minus 2 plus 4 pi r. Now we will do what? We will equate it to 0. Equating it to 0, we have minus 200 upon r square plus 4 pi r as equal to 0. Taking the LCM and solving it, so LCM will be r square, correct? So let us just write it here. We'll get minus 200 plus 4 pi r cube upon r square equals 0. We'll get minus of 200 plus 4 pi r cube as equal to 0. So we get 4 pi r cube as equal to 200. Now r cube will be equal to 200 upon 4 pi. So if you cancel it, you get r cube as 50 divided by pi. So what is the value of r that we are getting now? R is, we are getting 50 upon pi whole to the power 1 by 3. We have taken cube root on both the sides. Clear? Now this is the value of radius, and we will now differentiate the first order derivative, that is minus of 200 r to the power minus 2 plus 4 pi r. Again, because we have to show the surface area is minimum, for this we need to show the second order derivative of surface area as greater than 0. So let us solve it. Differentiating it again, we will get d square s by dr square equals to 400 r to the power minus 3 plus 4 pi. Correct? Now we have to put the value of r as equal to 50 upon pi whole to the power 1 by 3. So we can write 400 divided by 50 upon pi to the power 1 by 3. Its whole power is given as 3 plus 4 pi. So just to see, we are going to get all positive numbers. When you add them, you will get it as greater than 0. So we have proved that at r equal to 50 divided by pi whole to the power is 1 by 3. At this value of radius, the second order derivative of surface area is greater than 0. That means the surface area is minimum. Now we will calculate h, which is the height, because it is asked in the question to find the dimensions of the can, right? So we have calculated radius. Height was 100 upon pi r square. So we will just put the value of r here, which is 50 divided by pi whole to the power 1 by 3. Now you can simplify it. 100 can be written as 2 into 50 divided by pi multiplied with 50 to the power 1 by 3, right, and pi to the power 1 by 3. You can just apply the laws of exponent and can solve these two and simplify your answer and can write the value for height. So what we have done, we have calculated the dimensions of the can. When the volume was given, using the volume we have shown that the surface area is minimum. Clear? So this is how you will be doing question number 21. Let us proceed to our classwork questions now. So now the first question that we are going to discuss is question number 22. In question number 22, we have been given a wire of length 28 meters. So I'll just draw it in front of you. A wire, suppose it is 28 meters in length. Now it is to be cut into two pieces. So let us just take two pieces. Okay, now they're asking one of the pieces is to be made into a square. So I am considering, suppose it is 28, so this is x, then the leftover piece is 28 minus x. Now it is said that one of the pieces is to be converted into a square. So let us suppose this piece whose length is x meter is converted into a square. So let us just draw a square. Now if x is the total length of wire from which this square is made, that means this x is the perimeter for it. So the length will be of each side x divided by 4. Equal sides a square has. Now 28 minus x, from this piece of wire we are making a circle, as it is mentioned in the question that you are drawing a circle out of it or you are making a circle out of it. Now 28 minus x will become the circumference. So I am writing c as 28 minus x, which is of the circle, and x is the perimeter of the square. So the side of square will be x divided by 4. And from here we can calculate radius. 2 pi r is equal to 28 minus x. So r will be equal to 28 minus x divided by 2 pi. So we have got radius and we have got the side of square. Now it is said what should be the length of two pieces. That means we have to find out x, so that we can find out 28 minus x also. So that combined area, let us represent the combined area with t, which is the total area. Combined area of the square, that means we have to write the area of square plus area of circle is minimum. So we have to minimize t. That means we have to show the second order derivative of t as greater than 0. Now area of square is square of the side, so it will be x square divided by 16 plus area of circle is pi r square, so we will get pi multiplied with 28 minus x whole square upon 2 pi square will be 4 pi square. Clear? Now this is the total area. Now we see it is complete in the form of x only. We can differentiate it. So first of all, let us simplify it further. X square plus 16 plus, see, pi and pi will get cancelled, 1 upon 4 pi multiplied with 28 minus x whole square. So on a separate sheet we will now differentiate it. So what is the total area of square and the circle? It is x square by 16 plus 1 upon 4 pi multiplied with 28 minus x whole square. Clear? So differentiating it now, dt by dx, we will get 2x divided by 16 plus 1 upon 4 pi as it is. Differentiation of 28 minus x whole square will be 2 into 28 minus x, and of 28 minus x it will be minus of 1. So we get x divided by 8 minus, we can cancel it just to see. Okay, so we get 1 upon 2 pi into 28 minus 2x. This is what we are getting. Now what we can do is differentiate it. Now what we can do is put it as equal to 0. So putting it as equal to 0, let us take the LCM first. We will get 8 pi as the LCM. So it will be x pi minus 2 is already there, pi is there. So we'll multiply it with 4. 4 multiplied with 28 minus x equals 0. So we have x pi minus 4 multiplied with 28 is 112 minus plus 4x equals 0. Right? So now considering the two terms of x, we can take x common. We are left with pi plus 4 equals 112. So what we get, x is equal to 112 upon x divided by 4. So this is the value of x that we are getting. It is pi plus 4, not x plus 4. Clear? So this is the value of x we are getting. Now we have to prove the second order derivative of the total surface area, right, as greater than 0 for minimum. So this is the total surface area that we were getting. This is the expression, just to see. So see, differentiation of x divided by 8 will be 1 by 8 minus 1 upon 2 pi as it is. Differentiation of 28 minus x will be minus 1, which will make it as plus. So it is greater than 0 we see. At x equals 112 upon pi plus 4, we have the second order derivative as greater than 0. That means the area, the combined area is, or the total area is greater than 0. That means minimum. So what is the length of the side, or what is the length of the piece? That means it was total 28 meters it was, and we have to cut out into two pieces. So we have to find out the length of the pieces. One was x, another was 28 minus x. So you have got x, you can find out 28 minus x also. This is how you are going to solve the question. I am again repeating it for you once. A wire was there of 28 meter length. It was cut into two pieces. So I considered one piece as x and another piece as 28 minus x. One of the pieces is to be made into a square. We have done that, and another into a circle. So this x becomes the perimeter of this square. So the side is x divided by 4. Similarly, 28 minus x becomes the circumference. Hence the radius can be calculated from it. So we calculated the side and the radius. Now we had to prove that the combined area of the square and the circle is minimum. So what should be the length of this piece or these two pieces so that the area is minimum? For this we had to prove the second order derivative of area is greater than 0. So we have done that. Clear? Now let us go to another question. Question number 23. In this it is given that we have to prove volume of largest cone. A cone is there, it is inscribed in a sphere of radius r. Radius of the sphere is r and volume of largest cone. That means volume of cone is to be maximized. When we see largest cone, so it will have maximum volume. It can be inscribed in a sphere of radius r is 8 by 27 of the volume of sphere. So we have to prove that volume of the cone is equal to 8 divided by 27 times of the volume of sphere. Clear? Let us do that. Let us first draw the diagram, a sphere and a cone. So just to see in the diagram, I have drawn a sphere and inside it there is a cone. Now what we have to do is, I have considered, see, it is given that the radius of the sphere will be capital R, so representing it with capital R, so these two are the radius. I am considering this OC as X, so BC is what? The radius, and we need radius and height for writing the volume of the cone. So volume of cone is 1 by 3 pi r square h. So let us first also write that what we have to prove. What we have to prove is that volume of cone is equal to 8 by 27 times of volume of sphere. What is volume of sphere? 8 divided by 27 into volume of sphere is 4 divided by 3 pi r cube. Okay, now we can write it as 32 upon 81 pi r cube. If we prove this, we are done, right? So we have to prove volume of the cone, which is maximum, is this. So let us try to prove it. Now we will first of all consider this into either r or either h, then only we can differentiate it. So just see here, using in this triangle, if this is 90-degree angle, what I can write is that capital R square is equal to x square plus small r square, which is the radius of the cone. So small r square will come as capital R square minus x square. Clear? And what will be height? Height will be capital R plus x. Clear? This will be there. Now differentiating it, or first of all putting the values of r and h. So we see that is volume of cone will become equal to 1 upon 3 pi multiplied with r square is, we will put the value of r square as capital R square minus x square into h. H is r plus x. This is what we are getting. Clear? Now we can solve it further. Pi divided by 3, we will multiply first r with r square minus x square, so we will get r cube minus rx square, then plus x r square minus x cube. Clear? Now our purpose is to differentiate it first of all. So let us first differentiate it. Differentiating, what we will get is, so I will write dv by d. What we are differentiating with respect to? Just to see carefully, I'll just tell with which respect we have to differentiate. Now capital R is the radius of sphere, so on it the volume does not depend. The volume depends on x now, which is a part of height. So we'll differentiate it with respect to x. So differentiating it with respect to x, we get it as pi divided by 3. Now the expression is, just to see carefully, r cube. R cube differentiation will be 0. So we will write it as, so we'll get on differentiation this term. Equating it to 0, we have minus 2rx plus r square minus 3x square is equal to 0. Clear? Now solving it, it is a quadratic equation in r and x, just to see. So rearranging the terms, we have written r square minus 2rx minus 3x square equals 0. Splitting the middle term, we can write minus of 2rx as minus of 3rx plus rx. Taking r common in the first two terms and taking x common in the second two terms, we have two factors, r plus x and r minus 3x. From here, either r will be equal to minus x or r will be equal to 3x. So radius can't be negative, so it won't be possible. Now the only answer left with us is r equals 3x, or we can write x is equal to r divided by 3. Now at this value of x, we have to show that the second order derivative, what we have to prove? The largest volume, that means the maximum. So second order derivative for volume should be shown as less than 0. Let us find the second order derivative. So differentiating it again, we get d square y by dx square equals pi divided by 3 into minus of 2r as constant, differentiation of x will be 1, r square differentiation will be 0, and of minus 3x square it will be minus of 6x, right? So solving it, just to see, we have taken minus common, we are left with 2r plus 6x. So whatever value of r you place, which is obviously a positive number, x divided by 3 or 3x, so just to see, we are going to get it as negative only. So it is less than 0, that means the volume is maximum of the cone at point r equals 3x. So now this is the point at which the volume will be maximum. Let us find out or let us prove that the volume of the largest cone, that means the volume of the cone or the maximum volume of the cone, is equal to 8 divided by 27 of the volume of the sphere. So just to see carefully, the volume of the cone was, so this was the volume of cone. Now we are putting the value that we have got, 1 upon 3 pi r square minus r was equal to 3x. So x is equal to r divided by 3. So we get r square upon 9 into r plus r divided by 3. Solving it, we get 1 upon 3 pi. Taking 9 as the LCM, 9r square minus r square is 8r square multiplied with 3r plus r is 4r divided by 3. So solving it, we get 8 4s are 32, right? So 32 pi r cube divided by 9 3s are 27, 27 3s are 81. So just to see, we are getting it as equal to that we explained, right? Just to see here, 8 by 27 times of volume of sphere, which is 4 by 3 pi r cube. So if you solve it, you get 32 upon 81 pi r cube only. That is what we are getting. So we have proved that the maximum volume of the cone, which is inscribed in a sphere of radius capital R, it is 8 by 27 times of the volume of sphere. Okay, so I'm again repeating it what we have done. We had to prove that the volume of largest cone. So from this statement you get to know that volume of the cone is to be maximized. That can be inscribed in a sphere of radius r. So sphere radius is given, whatever is given we have to make use of it, right? So I have made use of capital R inside the diagram, just using the Pythagoras theorem I made the use. So it is 8 by 27 times of the volume of sphere that we will be proving at end. So first of all, you have to get the volume V of the cone which has small r and small h as the radius and height. So we will get r in terms of capital R, small r in terms of capital R, so that we have an expression of r and x, right? And we can prove our volume as 8 by 27 times of volume of sphere. So in homework part, what you are going to do is, we have done like 5 questions almost today. So you are going to complete these questions as well as along with this of the exercise. So you need to do questions from 21 to 26 in your homework notebook. Also do practice the same classwork questions in your notebook without having a look on the answers. So for more videos like this, do subscribe the channel AdQuark and keep liking and sharing the videos.